Hello everyone, and greetings to our lecturer. Today, my friends and I will present about our Lab 4 experiment, which is electrical resistance and Ohm's law. So, without wasting any time, let's get started. So, here are my group members. Me, Eldora Abi, and my friends Inas Takia and Nurza Atika. Before we start our presentation today, let me explain to you the objective and the hypothesis of this experiment. The objective of this experiment is to find the resistance of the given resistor, while the hypothesis states that if the value of the resistance is high, the value of the emitter and the voltmeter will be reduced. Now, let us move on to the theory of electrical resistance and Ohm's law. The relationship between the three important electrical quantities, current, voltage, and resistance, was discovered by a German scientist, which is George Simon Ohm in 1827. In Ohm's law, it states that the voltage or potential difference between 2 points is directly proportional to the current or electricity passing through the resistor, and directly proportional to the resistance of the circuit. The formula of Ohm's law is V equals to IR, where V represents the voltage, I is current, and resistance is a capital R. It was such an important discovery that the unit SI of the resistance is called the ohm. In this experiment, the purpose of the resistance is to reduce the current that through it. The application of Ohm's law helps us in determining either voltage, current, or impedance or resistance of a linear electric circuit where the other two quantities are known to us. It also makes power calculation simpler. However, there are some limitations to Ohm's law. The first one is Ohm's law is not applicable to unilateral networks, as unilateral networks only allow current flow in one direction. Thus, it does not have the same voltage-current relation for both directions of current. For example, diode and transistor. Secondly, it is not applicable to nonlinear elements. Nonlinear elements are those which do not have current exactly proportional to the applied voltage, which means the resistance value of these elements change for different values of voltage and current. The example of nonlinear elements is thyristor.
Next, for the experimental design, this is a series circuit that was set up for this experiment. The materials that have been used in these experiments are switch, voltmeter, ammeter, connecting wires, power supplies, which is battery, resistor, and another resistor used as a rheostat. For the procedures, first is the circuit was set up in a series like had shown before, which contain power supply, switch, resistor, voltmeter, ammeter, rheostat, and connecting wires. Second, the rheostat was set up to 20 ohms. Third is the switch was closed and read the voltage and current amount on the voltmeter and ammeter, and then the data was recorded. Next, repeat the readings until 5 times by changing the resistance of rheostat. After that, data for all the 5 readings of voltage, current, and resistance of rheostat were recorded into a table. And lastly, a graph was sketched from the data collected.
The data shown different rheostat value gives different ammeter and voltmeter reading. The graph shows the relationship between the voltmeter and ammeter readings. The gradient is the amount of resistance. The resistance obtained is 10 ohms using the gradient formula. Observation. The graph shows that the higher the voltage, the higher the current. Ohm's law is confirmed because the voltage is directly proportional to the current. This means that when the voltage increases, the current will always increase as long as there is no resistance or if the resistance remains the same. The power supply is 5 volt. For example, in this experiment, the voltage increased from 0.45 volt, 0.56 volt, 0.71 volt, 1.0 volt, and 1.67 volt. while maintaining the same resistance so that the current increase each time the voltage increase. The law can be shown when dividing voltage by current to obtain the value of resistance. The total resistance obtained is 10 ohms based on the above calculation. Therefore, the higher the voltage, the higher the current. Conclusion: the whole experiment has succeeded in proving that the change in voltage affects the amount of current flowing in a series circuit and can prove the Ohm's law. The amount of resistance obtained from the value of the gradient of the graph. Ohm's law has been verified where the voltage is directly proportional to the current obtained from the graph. A voltmeter is used to give a reading of the total voltage from the battery used to ensure the total voltage given from the battery is correct and the result will be more accurate. Thank you.